In this example, we are going to minimize average cost. So we've got a small publisher's cost for producing X books can be modeled by this cost function 800 plus 0.4x plus 0.0002x squared. We want to find the production level, so that means number of books, that minimizes the average cost per book. Okay, so with all of these optimization problems, again, you want to make sure that you know what you're doing. Are you maximizing or minimizing? And what is it that you're maximizing or minimizing? It should be clear from reading the question. So we have minimizing, right? We want to find the minimum of the average cost. So this can help us to see then what is it that we're going to need to build a function for or build a formula for. So cost and average cost are different. You can look back in your notes for a formula for average cost, and that's what we're calling C bar. So C bar has a formula for it, and that is the total cost divided by X. So to find the average cost function, you're just going to take the entire cost equation and put it over X, or divide the whole thing by X. Now I know that I'm going to want to find the minimum of this function. The way that it's written, we've got a quotient. You could use the quotient rule on this. However, that would be overkill and a lot more work than if you were to just simplify this a little bit first. So when we are dividing by a single term here, a monomial, just dividing by X, what we can do, we have a couple of ways that we could think about this. We could split up this thing into 3 separate fractions here and divide each of the things in the numerator by X. Another thing we could do is bring up this X to the -1, or bring up this X and make it X to the -1. And if we're going to do that, we would then change this divide to multiply the entire stuff in the numerator by X to the -1. Then we would need to distribute that X to the -1 into each of these terms in the numerator. So I'm going to write it that way because I know that I've done it the other way before. So here's another way that you might think about that. Let's bring this up to the top. But since all of this is being divided by X, we have to multiply all of it by X to the -1. So now we've gotten rid of our quotient, but we've actually turned that into a product. Again, we're going to want to find the derivative of this. So to get rid of that product, we should probably distribute that X to the -1 into the parentheses. Okay, so that'll give us 800 X to the -1. X times X to the -1 just gives us 1, so we'll just have a plus 0.4. Then we'll have 0.0002x to the +1. Okay, so here's the function that we want to find the minimum of. So let's go ahead and differentiate this. Okay, so we'll find C bar prime. So we'll bring the -1 down and multiply. That'll give us -800 x to the -2. The derivative of the 0.4 is 0, so that goes away. And then we've got plus 0.0002. Okay, we want to find where this has a minimum, so we're going to set the derivative equal to 0 and solve for x. There's only an x in one spot. There are a couple ways you could go about solving this for x. You could rewrite this as a fraction and kind of try to isolate with doing some cross multiplying. Or you could just isolate that x to the -2 and raise it to the appropriate power on either side to get rid of the -2 exponent. So I'm going to do it the second way. I'm going to add this stuff over to the other side and just try to isolate the x to the -2. Before I try to raise anything to a power here, I want to get rid of that 800. So we'll divide both sides by 800. This is probably a very small number. Let's see what that comes out to be. Yeah, there's a lot of zeros there. I'm just going to leave it as that fraction for now, because when we kind of raise it to another power to solve for x, it'll actually end up being a bigger number. Okay, so in order to solve for x here, you want to think about raising both sides to an exponent that would give us a result of x to the first on the left-hand side. When you raise a power to a power, you multiply the exponents. So we want to think about what we need to multiply -2 by in order to give us a +1. And that's, of course, going to be -1/2. So that'll multiply to give us a 1 in the exponent. So we've got to take that 0.0002 divided by 800 and raise it to the -1/2 power. And when you do that, you get 2,000 out. Okay, so 2,000 books, right? X is representing books in this case. We found a critical number, but remember that these can be maximum or minimum values. So we just want to make sure that we actually did find a minimum and not a maximum. So this is a crucial step. We want to verify we found a min. So you could make a sign chart and use the first derivative, or you can use the second derivative. I like to always use the second derivative test because it tends to be simpler in a lot of ways. So if we find our c bar double prime, we're going to take c bar prime and differentiate it. So let's bring the -2 exponent down and multiply the -800. That'll give us +1600. Then we'll subtract 1 from the exponent, so we'll get x to the -3. The derivative of the 0.0002 is 0, and so here's our c bar double prime. This is the same as 1600 over x to the +3. Now remember, what we want to do is figure out the concavity of the original function at our critical point. So at x equals 2,000, is the function concaving down or is it concaving up? That is the role of the second derivative. So we're going to plug in 2,000 for x into c bar double prime. Now we don't care about what this actual number is, we just care about its sign. We've got all positive numbers here, so this is just going to be a positive number out. The second derivative being positive means we've got a smiley face, concave up like this. So that does mean that we did find a minimum, and that's good because that's what we were looking for. Okay, so I think that that's it. We just wanted to find the production level that minimizes the average cost per book. So that's just looking for how many books should be produced. And so we found 2,000. So let's write this in a little summarizing sentence here. So to minimize the average cost per book, um, 2,000 books should be produced. You know, what we should probably do in order to just check our work is to graph our average cost function in a calculator or in the internet and make sure that our minimum kind of makes sense, just to see if we did everything right. So take out your calculator or go to desmos.com and we can plot our original cost, average cost function. So let's see, it is 800, well, we can graph either one. I'm going to do this one, 800 plus 0.4x. Okay, so 800, I'll do parentheses, 800 plus 0.4x plus 0.0002x to the second. We'll close our parentheses, and that's all divided by x. Now, I don't see anything here, but our x value that we found was 2,000, so I'm just going to kind of shrink my scale here. Oh, it's way out here. And it gets really flat, so I'm gonna just try to zoom it. I'll change my scale a little bit. This would be really hard if you were on a regular, calculator. So Desmos is great. If you want to download it onto your phone even, you can kind of squeeze things and point at stuff, and it kind of gives you a coordinate. So actually, there we go. So 2,000, there's the minimum there. That 1.2 would be the actual average cost per book. And it does look like, we've got a minimum right at that point. So we did a good job. And that's an example using minimum average cost. I've got one more example for you if you'd like to check into that. It's a little more complicated. And we will talk about that in the next video. So I hope to see you then.